Hello everyone. So in today's class, what we'll be learning is the difference between diamond and graphite. As we have learned, diamond and graphite are nothing but covalent solids, okay, belong to the same category of solids, okay. Covalent solids are those solids, okay, which have a network of non-metals bonded to each other. Their characteristic properties are they are hard, they are non-conductor of electricity. But what we have learned last class is that graphite is an exception, which is very soft and which is a very good conductor of electricity, while the other class of covalent solids, or if we talk about diamonds, they are very hard and non-conductor of electricity. So why that difference in characteristics or properties in diamond and graphite? That is what we are trying to learn today. Okay, so let us move ahead. So graphite and diamond both belongs to the covalent solid, whereas diamonds are hard and non-conductor of electricity. Graphite are soft and good conductor of electricity. So that's the basic difference between diamond and graphite. Both are covalent solid, but covalent solid general characteristics are they are very hard and non-conductor of electricity. They are one of the toughest material found on earth. But graphite is very soft and good conductor of electricity. So how do we explain such fact? So that is what we are trying to understand today. So if you see diamond, okay, so diamond structure is basically something like this, okay. So if you can see all those dots, okay, the circles represent carbons, okay. So if you see one particular carbon, if I see this particular carbon, this carbon is bonded to other 4 carbons. I hope everyone can understand diamonds and graphite are nothing but allotropic form of carbon, right? They are nothing but pure carbons only. So if it is carbon, we know that carbon has a valency of 4. Now this particular carbon in diamond is bonded to the next 4 neighboring carbon actually in a tetrahedral manner, okay, and all the 4 valency of carbon is used in the process. You can clearly see, okay, the geometry is tetrahedral and all the 4 actually bonds are used, and one carbon will be bonded to the next 4 carbon, okay. You can see now this will be bonded to next 4, this will be bonded to next 4. So you can just see that how it can just grow actually like a tree, okay. It just go on and go on and go on and go on and form branches and branches and branches, and it goes on forming that network. Now see, this particular carbon is linked to this last carbon by a series of covalent bonds, no, by a network of covalent bonds. That's why we call them network solids, okay. So in carbon, what you see is each carbon is tetrahedraly bonded to the rest 4 carbon. So basically it is sp3 hybridized, okay. As a result, what will happen is all the 4 valency of that particular carbon is used. Now carbon has 4 valence electron which is used in bonding, and they are forming strong network bonding of covalent bonds. As a result, they become very hard. Since all the 4 valence electrons are used, there is no electron left, so there is no free electron in diamond. As a result, it becomes a very poor conductor of electricity. So basically, what is the difference between diamond and graphite, or the characteristic properties which is differing in diamond and graphite, is basically due to its structure. So if I just try to see now, so in diamond, each carbon is attached to 4 carbon atom tetrahedraly by strong covalent bonds. As I've told you, the carbon atom here are sp3 hybridized, and the bond length of carbon-carbon atoms are equal. Hence, diamond forms a 3-dimensional network of strong covalent bonds. So it is hard, as I have explained it to you. All the 4 valence electron of the carbon are used up in covalent bonding. No valence electron is free. So diamond is a poor conductor of electricity. As I have told you, all the 4 valence electron which are available in carbon is used in forming strong 4 covalent bonds, okay. As a result, there is no electron left. If there is no electron left, carbon becomes a very poor conductor of, or carbons or diamond becomes a very poor conductor of electricity, okay. Let us try to see what happens in graphite. So this is graphite, okay. So if you see graphite, what is happening is in graphite, one carbon, okay, you take any one carbon, let us take this carbon. Now this carbon is bonded to how many carbon? If you see, it's basically bonded to 1, 2, and 3. Any carbon you pick, this carbon, 1, 2, 3. So what is happening in graphite is each carbon is bonded to next 3 carbon atom. Okay. As a result, it does not form a tetrahedral structure, it forms a planar structure. Now, what will happen is, as it goes on, it will form actually a planar structure, and you can see it forms hexagonal rings. Okay. So you can see it forms hexagonal rings, and it will be sheets of hexagonal rings. Okay. So it will form a planar structure with a sheets. Okay. Sheets of this actually carbon atoms. So it will form a long sheets of this particular carbon atom. And then what will happen? Another carbon, another group of carbon atoms will form another sheets, another carbon atom will form another sheets. So what will happen is now this particular sheet, which is formed by one group of carbon atom, and this particular sheet, which is formed by another group of carbon atom, are not bonded to one another. So all the carbons are bonded to the next 3 carbon atoms, okay, means in a planar structure. And when they form these layers are not bonded to one another. How we can prove that? The carbon-carbon single bond, if you see in graphite, is 141.5 picometer. Okay, that is the length of a carbon-carbon bond. If you see this particular, if it is a bond, okay, which we are showing by dotted line, it should be 141 if it is a carbon-carbon bond. What we found out that it is not carbon-carbon bond, because it is 340 picometer. That means it is longer than carbon-carbon bond. So this is not a carbon-carbon bond. Basically, this is just a intermolecular, or it's just an interaction. Such interaction we call as van der Waal interactions. And this van der Waal interaction just holds this 2 layers together. Okay. So as a result, this 2 layers will not be bonded to one another. So if they are not bonded, they can slide on top of one another. So if they slide on top of one another, what will happen is they become slippery. They become soft. Okay, which you cannot see in the case of diamonds, because in diamonds, what happens is carbon is forming 4 bonds. When it is forming 4 bonds, there is no way that it can form a planar structure. It goes for 3-dimensional network structure, that is tetrahedron. Okay, but over here, since it forms planar structure, as a result, one plane sheets on the top of another plane sheet will slide on top of one another, since they are not bonded to one another. And more importantly, if a carbon is forming 3 bonds, what we know is carbon usually forms actually carbon has a valency of 4. It prefers to form 4 bonds. So if it is forming 3 bonds, that means one bond is, or one particular electron is remaining as it is. Okay, this particular electron in each carbon. So imagine that all the carbon will have one electron free. So they form a pi cloud over there, and this will be delocalized. Okay, they will be free. And when they will be free, what they can do is they can actually move if you apply a potential difference. As a result, what will happen? Graphite becomes a very good conductor of electricity. So that's the basic difference. Okay, so the structural difference between diamond and graphite makes the whole change in properties of diamond and graphite. Okay, so let us just try to see the main points. So in this case, carbon atoms are arranged in different layers in which, okay, every carbon atom is linked to 3 neighboring carbon atoms. As I have told you, it will be linked to 3 neighboring carbon atoms. The carbon atom in the graphite structure are sp2 hybridized and are directed in the same plane. See, that's what they are directed in the same plane, thus forming hexagonal rings. These rings have many layers of particles. Thus, the 4th electron of each carbon atom is free to move about. Because of the presence of these free electrons in different layers, graphite becomes a good conductor of electricity. Further, the distance between the adjacent layer is greater than carbon-carbon bond length. Hence, these layers are not bonded, as I have told you, to each other. For this reason, graphite is soft. Okay, so remember that this is how, okay, that is what is the basic difference between diamond and graphite. So why diamond and graphite, being a covalent solid, differ from one another is because of their structure. Diamond is tetrahedral structure, whereas graphite is planar structure. Diamond is sp3 hybridized or have sp3 hybridized carbon, whereas graphite has sp2 hybridized carbon, because of which diamond becomes very hard, graphite becomes very soft. Diamond becomes poor conductor of electricity, graphite becomes a good conductor of electricity. So that is how actually we can learn the basic difference between diamond and graphite. Being both actually covalent solid, they differ from one another due to their structure. Okay, so that is how we can understand what is the difference between diamond and graphite.